Today we're going to take a look at the 3 merge sort algorithm challenge from Topcoder. Okay, so merge sort basically takes an array of objects or items or numbers or whatever, breaks it down to its smallest possible atomic unit, which would be one item in an array, and it does this recursively. Then it compares that item with another item and creates a sorted array by stacking up those or by pushing those smallest units or elements into a final array. Now, merge sort typically does this binarily, so it's usually comparing only two subarrays until it builds back up to the final sorted array. But today's array is going to actually take a look at a merge sort method that divides the primary array 3 ways instead. So, as I said, instead of breaking it down into 2 subarrays, we're going to be breaking it down into 3 subarrays, and then merging into the final sorted array using the same method. Now, because this method is recursive, as I said before, it will break each of the arrays or subarrays down to their atomic units. So there will be one item in each array, and then it will build up the sorted array by pushing the smallest elements compared with each of those 3 into a final sorted array. So let's go ahead and talk about this main method. So we define the main method as 3merge_sort, and we're passing in an array. Now, if the array is less than or equal to size 1, we're going to return that array because that array is already sorted. So again, if it's an empty array that's trying to be sorted, it will return an empty array. If the array only has one item in it, it will return that one item. However, if it contains more than one item, it will run through the final sort. Now, what it does is it divides this array into 3 subarrays. I called these left, center, and right because looking at array written out on a piece of paper, you'll see the division into left, center, and right. Now, the left side is going to be the first third of this array. So from 0 to the array size divided by 3 is the first third. Center will be the second third, so that array size divided by 3, notice it picks up where the other one left off, to 2 times the array size divided by 3, so 2/3. So from 1/3 to 2/3 will be the center. And then finally the right is that last remaining third of the array. So from 2/3 of the array to the array end, or the array size, that's going to be the final third of that array. Then, after I have those divided, we run the 3merge_sort method. So again, this method is going to keep running recursively until we get to that atomic subunit. Once it reaches that atomic unit, it runs the merge3 method. So you can imagine this left unit being divided down all the way down to 1 unit. When it gets to 1 unit, it will return that array size. Then when that array returns, it checks the next part of the array, which would be the center of that left array, and returns it to its atomic size, and then same thing with the right. And then we're going to be merging those 3. So merge3 will take the left, center, and right, which we've defined up here, and we'll start combining those by comparing the first item in that subarray. Now, the reason we're comparing only the first items in each of those arrays is because as the method starts building back up, the arrays that are returned, so those atomic units are returned into subarrays, which are returned into potentially subarrays, larger subarrays, and then finally the final array, all of those subunits will be sorted because of the methods that we're going to be describing. So because they're sorted, when I'm combining larger and larger arrays, I only want to look at that first unit because that will be the smallest unit in the array itself. So as I'm building up the arrays, I will look at each of these until one of the arrays are empty. So if any of those arrays are empty, I have to jump out of this while loop and go to merge to, the merge to method, which I'll talk about in a little bit. The merge to method will combine two of the subarrays, but right now the merge 3 method will first take a look at this left unit, and it's going to be that first unit in the left. And I could have said left.first, but here I just used index 0 because it's the same thing. And I'm comparing it to the center first unit, and if left first is less than center first, then I'm going to push into this new sorted array that I've created here. The value that returns from the ternary method, or the ternary block, when comparing left 0 to right 0. Again, left first to right first. If left first is less than right first, it will shift out that value at the index 0 into that sorted array. So we'll push that shifted value into the sorted array. If left first is greater than right first, it's going to push the right, or shift the right value into the sorted array. And that's if left is less than center. However, if left first is greater than or equal to center, then I need to start comparing the center and right array first indices. I'm going to compare whether or not center first is less than right first. If center first is less than, then I'm going to shift the center value into the sorted. However, if right first is less than, then I'm going to compare the right first into the sorted. So we'll keep doing this, comparing each of those first items until one of the arrays has been emptied. And it's being emptied by using the shift method that's built into array objects in Ruby. So once we have an empty array, so it will be one array is empty and the other two have something in it, whether that be one item or multiple items, it's going to have to jump out of this while loop. And the reason is because if we try to compare a first value to a nil value, that doesn't work. It will throw an error. So we can't compare values to nil in any sort or fashion or form because the comparator doesn't work. So we have to jump out into the merge to method. And I pass into the merge to method the sorted array that we've been building up, because we have to keep building into that sorted array, and then left, center, and right. Notice I'm passing all three of these values in. And the reason I'm passing 3 values is because once we get to the merge to method, we have to check to see which of the arrays has been emptied. And then when we figure that out, we sort the remaining 2 arrays using that same method by comparing that first element and then shifting that into the sorted array, the smallest element into the sorted array. So again, if left is empty, then I'm comparing center and right. And I'm using the same method that we used up here in the merge 3, just comparing which one's less and then sorting in or pushing that smallest unit into sorted. Now, once any of these values or arrays are empty, these subarrays are empty, then what I do, because the arrays are in sorted order, the subarrays are in sorted order, then I just concatenate the sorted, which will be whatever's been pushed in from the previous merge 3 sort and the sort here, and then I concatenate that with center and right, because if there's anything left in those 2 arrays are already sorted, so it's just going to attach it to the end of the sorted array. However, if center is one empty, then I'm going to compare the left and right arrays, and finally, if the right side is empty, I just wrote an else here. If the right array has been emptied, then it's going to compare left and center. And again, once any of those remaining 2 arrays are emptied, it just concatenates the remaining values to the end of the sorted array. All right, so let's go ahead and see that in action. So just as with my previous sort methods, I build in a test block, and this is just to test 10 random numbers from -100 to +100. And this is just for my own edification, and if you want to play around with the method outside of the RSpec, then you can go ahead and run the file itself, and it will run this test method here. And you can actually change the values to whatever you want to change them to. And you can go from -1000 to whatever. Just don't go too deep recursively. Well, that's not really an issue with 10 values. But if you do choose something crazy like, I don't know, 1 million here, you could run into an issue with the recursive method, in which it will basically overload the heap, and then it faults out. So again, just be careful, because this is a recursive method, not to try to sort too many numbers. Okay, so basically I take that shuffled array, which is a new value of random numbers between -100 and +100. I display that array, and we'll see it in a second, and then I go ahead and use the 3-merge sort to actually sort the shuffled array. So let's go ahead and do that. The random array, as you can see here, it's very random. It takes numbers all the way from -53, and there's actually 2 of those values there, so we can actually see if it duplicates. And deals with negative values and positive values. If it deals with negative and positive, it usually deals with 0 just fine. So then it returns our sorted array. Okay, and then finally, let's go ahead and run the rspec. So let's clear our screen real fast. Bundle exec rspec, and this is in the spec file, and it's called 3merge sort spec.rb. 7 examples have been passed in. We can see the details of each of those examples, and there have been 0 failures. So again, if there are any questions or comments, please feel free to post them in the forum, and I'll answer them as soon as possible. That's it. Thank you.